Hey, welcome back to Fat Mama Physics. In this video, we're going to talk about dividing rational numbers. We just finished with multiplying rational numbers, now with dividing rational numbers. And again, we have a board game to kickstart our show. To be honest, I don't remember if I shown this one before. But anyways, I just thought a concept in here was really cool that kind of related to dividing rational numbers a little bit. So the one thing in dividing rational numbers, especially with fractions, is that if you flip the division sign, you can flip the second fraction around. And I'll show you why in a second. But anyways, if you flip the sign, flip the second fraction, the result is the same. And that's the concept I want to highlight with Tragedy Looper. So again, I'm going to go to my phone to show us the rest. So here's the board. It looks very pretty, good artwork, and it's called Tragedy Looper. The game is about 3 protagonists, as you can see in the front. They are trying to solve a mystery or to prevent a tragedy from happening. The person causing the tragedy is this mysterious person here in the back. He's called the Mastermind. This is half collaborative, so a cooperative game, so 3 versus 1, Mastermind versus protagonist. I often like to be the Mastermind because it's very fun trying to engineer the tragedy from happening and trying to bluff or trying to mislead the protagonist from solving the mystery. So I'm loving that's pretty fun in itself. Here's the board. It looks very pretty. It's got 4 separate boards of 4 locations. As you can see, we have the hospital, we have the city, we have the shrine, and the school. And notice these characters. There are some characters here that are at these locations, and they can definitely move around into the locations, but there are some restrictions. For example, this patient over here isn't allowed to move into the shrine, isn't allowed to move into the school, as well as the city. Basically, he's stuck in the hospital. The funny thing I like about this one is some reference to certain animes, I suppose. For example, the office worker is not allowed in the school. Yeah, look at this guy here. He could be a creeper of some sort. But anyways, it's just it's very funny. Anyways, so the basic idea here is the Mastermind is trying to do certain things to these characters by playing these cards where he gets to move them, increase their paranoia, or whatnot. So the Mastermind tries to do this secretly, of course, because these cards can be played face down, and the protagonists are trying to do the same thing. So they try to also move the characters, to maybe trying to screw up with the Mastermind's plans, but also to give these guys goodwill, because notice at the bottom of the character card, there are some things you could, if you have enough goodwill, you can activate those abilities for the players, for these characters. So yes, so that's the idea, and what I want to show us is how these cards will be able to resolve. The one that is interesting is the movement. Okay, so for example, for movement, let's have this up here. For example, if what could happen is the Mastermind goes first. The Mastermind plays 3 cards on this entire board. Can be on players or could be on the locations themselves, and then the protagonist does the same thing. So the protagonist could very well put another card on this player. Once all the cards are played, then they reveal and resolve. I guess the Mastermind resolves first. But notice for movement tends to combine. So for example, if I have a horizontal and a diagonal movement together with the Mastermind and the protagonist, then his office worker moves diagonally up to the shrine. Okay? So that is the cool thing about movement, especially if you want to try to screw up the Mastermind's plans. And what I want to mention that is related to the concept of dividing rational numbers is that when you divide fractions, it's exactly the same thing as multiplying by the reciprocal of that fraction. So for example, if I have these 2 movements here, played by the protagonist and the Mastermind, notice that if I go sideways and vertically, I get a diagonal, but if I had switched them, if I had flipped their movement directions, then I still, in the end, get exactly the same movement, which they move diagonally. So that's the idea with dividing fractions. If I flip the fraction, if I multiply by the reciprocal, that gives me exactly the same answer. So doing that doesn't change anything. Just like changing the direction of the movement, after I combine them together, I'm still going to get diagonal movement on whoever it's going to be. Okay, so that's the idea that I wanted to introduce with Tragedy Looper. And this great, awesome looking game here. I thought it would be cool, especially some of you do watch anime, might appreciate the art here. Anyhow, this is it. This is Tragedy Looper. Great game. And I will get back to dividing rational numbers. Time to pack this game away. Okay, so hopefully you enjoyed that introduction to Tragedy Looper. The one thing I mentioned about that game, which is really cool, is the fact that you can design your own scenarios, especially as a mastermind. It's really fun to do that. Okay, so sorry about that. Let's continue with dividing rational numbers and talking about what I mentioned before, where you have to, you can flip the fraction to divide them. So I think I can finish everything in one video. So let's do some quick review. If I multiply two fractions, I can divide by their reciprocal. So in this one, what that means is I would have 3 over 5, and instead of dividing 2 over 7, I multiply the reciprocal of this fraction, which is just flipping the numerator with the denominator, which is 7 over 2. Now once you have that, you can easily multiply the numerator and the denominator just like we did in our last lesson. So 3 times 7 gives us 21, and I have now 5 times 2, which is 10. This is as simple as we can get, so there you go. You might be wondering, well, you're just telling me rules, Miss Lee, but how does it work? Why are you able to multiply by the reciprocal? Why is that the same as division? Okay, here let me give you a quick example. Let's take an example where I have, say, 4. Let's see, I'm dividing 2 into, divided by quarters, okay? So if I have to represent this on with a diagram, what this means is I have 2 big whole pizzas like that. Okay, I have 2 of them, and I'm going to divide them into quarter pieces. After I divide them into quarter pieces, how many pieces do I have in total? So if I do this one visually, that means I divide my pizzas into quarter sizes, just like that. Okay, after I divide my 2 pizzas into quarter sizes, I count how many total pieces I have. 1, 2, 3, 4, 5, 6, 7, 8. I have a total of 8 pieces. Lots of pieces. If I divide it into halves, I'm not going to have as many pieces, but each piece is really big. Okay, so then how does this how am I able to represent this one as a multiplication of the reciprocal? Now, after doing that, let's say I flip it. I'm going to get 2, and flipping the division, I get a multiply, and flipping my 1 over 4 gives me 4. I get 2 times 4, which is exactly 8. So if I have to revisualize this, what this means is I want to find a way to basically take 2 pizzas that I have. I need to multiply, I need to basically churn up 4 pieces per pizza. I need every pizza, I want them into 4 pieces. I want 4 times the amount of pieces that I could have. So it's kind of like saying that I have 4 pizzas and, sorry, I have 2 pizzas and I need to be able to have many pieces to give to other people or something like that. That's effectively dividing by quarters. So if I divide everything by quarters, I am going to get exactly 8 pieces. Okay, so it's kind of, that's kind of the idea. Notice that if I divide by a fraction, I also get a fraction less than 1. Notice I also get a bigger number as a result of that because I'm dividing by smaller pieces. It's as if I'm saying how many quarters can I fit into 2 pieces of pizza, 2 large pizzas or something. Okay, back to some examples. Again, If I'm doing division, I need to convert these mixed numbers into improper fractions. So we should do that first. Here we have 1 times 3 gives us 3 plus 2 is 5 over 3. And I'm not going to do the reciprocal yet. Let's do the improper fraction first. 4 times 7 is 28 plus 1, 29 over 7. Now I can flip my fraction around. Be careful though, I have a lot of students who flip both fractions. You're not flipping both fractions, you're only flipping the second one. 5 over 3 multiplied by taking the second fraction, flipping the numerator with the denominator, I get 7 over 29, and this becomes a multiplication sentence. Nothing to simplify. 5 times 7, it gives me 35. 3 times 9 is going to be 7. 3 times 2 is 6. 6 plus 2 is 8. So 87. Okay, that is my fraction. I can just leave it like that. Okay, and in the last example here, I'm not sure if there's a negative sign. I think there's a negative sign here in front of the 5. Anyways, it doesn't matter if you have a negative sign. Dividing and multiplying, you're always going to follow that same rule. 2 positives, 2 negatives gives you a positive. Negative and a positive is going to give you a negative. So same idea here. I am going to do a multiply by the reciprocal. This is 7 over 25 multiplied by negative 5 over 14. Okay, and again, let's see if I can simplify a few things. 14 I can simplify and make that divided into 7s. That's going to be 1 and 2. Divide this by 5 is going to be 1. Divide this by 5 is going to give me 5. So this I am left with 1 over 5 multiplied by negative 1 over 2. That's easier to deal with. I'm going to get negative 1 over 10. Negative tenths. Last example here, I'm going to take 3 and I'm going to multiply by the reciprocal, 8 over 7. So I can make this 3 over 1 as a fraction, or I can just take the 3 and multiply by my numerator directly. 3 times 8 is 24 over 7, and this is the most simplified form. Okay, so again, we're going to reiterate the fact, and I mentioned this just earlier. If I have two rational numbers, they have the same sign, meaning if I have negative divided by negative or positive divided by positive, these are going to both give me a positive quotient. The quotient is the answer of the division, whatever you're doing, okay? If I have two numbers that are opposite in sign, say positive and negative and positive, my final answer is going to be negative. Okay, so before you do any of the division and a multiplication, you can always predict the sign first. For example, for this first question, A, I can predict that my final answer is going to be positive, so I don't need to worry about the negative sign at all. Now to figure out what this is going to look like, this is 3 over 2 multiplied by 5 over 1. And I just drop the negative sign because I know my answer is going to be positive. This is 15 over 2 equals 15 over 2. Okay, and I think all these numbers are the same here. They're all the same. Great. So this is also 3 over 2 divided by 1 over 5. So it's exactly the same as before, the same numbers, except I'm working with two positive numbers. And last but not least, with this decimal here, this is, to be honest, for a decimal, I would just go ahead and put it in the calculator. And I know that this is going to be a positive number. I don't even have to worry about putting that in my calculator here. I get, a really ugly 0.833 repeated, or 0.83 repeated. And hey, that's exactly if I deal with the two positive numbers anyways, 0.83 repeated. Done. Okay. Next up is what happens if I have negative numbers. One of them is negative. My answer is going to be negative. So I think all of these are exactly the same numbers I had above. So really, I just have to put negative signs in front of each of them. Negative 15 over 2. This one is also going to be negative 15 over 2 since the negative is here for a second question and negative here for the first question. Same thing here, I have one negative sign and exactly the same question as the one above. So I'm going to get negative 0.83, and same thing over here. I have one of the numbers being negative, negative 0.83 repeated. Okay, here we go. Okay, so then next up we have some more examples. Ooh, hey, here is, okay, so here it's a little shortcut. Again, I'm only a fan of the shortcuts if you've done a lot of problems and you're comfortable with it, but I would just say that whenever you're doing math, go with the basics. As long as you have the basics, you don't need all the shortcuts. Okay? Especially the shortcuts you're going to make, if you're going to make mistakes doing the shortcuts, or you're going to mix up the different shortcuts, then I don't recommend the shortcuts. Always stick with the basic principles, because it's always consistent across the board, no matter what question you're doing. So for example, this A question, notice you have a dividing another fraction. If you divide by another fraction, it's the same as multiplying by the reciprocal. This common denominator method means that if you have the same denominators, you can just divide the top number. Sure, you can do that. But let me show you why you can do that. For example, this one, 7 over 8, I can also multiply by the reciprocal. I have 8 over 14. And guess what? I can simplify this. 14 can simplify to a 2 if I divide these two by 7. And then 8 just becomes 1. And this just becomes 1. I get 1 times a half. 1 times a half is just equal to 1 half. Okay? So let's go back to the common denominator method to see how this works. If I have the same denominators, I just have to divide the numerators. 7 divided by 14 is indeed 0.5 or 1 half. Okay? And the reason why is because notice the 8s, once I flip one of them, are able to cancel out. So if we do D as a separate example, this one I could just say, the denominators are the same, so I take negative 15 divided by 3. This should give me negative 5. Okay? But let's see why it works. Let's see why it works. Negative 15 over 7 multiplied by 7 over 3. I notice that my 7 here cancels out, and my 3 and my 15 here cancel. I have negative 5 divided by 1, and this is going to give me negative 5, since I have negative 5 times 1. Okay? So again, if the shortcuts are too confusing or if you don't feel comfortable with them, don't do them. I mean, once you've done enough problems, the shortcuts will come to you naturally. Especially if you try to learn too many shortcuts, you're going to get the shortcuts confused and make mistakes. So always stick with the basic principles, which we will do right now. Starting with A, multiply the reciprocal of the divisor. So doing some examples here, let me give you, since I've done A and B in the previous question, maybe it's a good time to pause the video for you to try this problem. Okay, so this one here, I will, you know what? It's exactly the same as the top, except we have a different denominator. Well then, let's just go over it anyways. So again, I recommend just doing the reciprocal, multiplying by the reciprocal, because you'll notice that the 8s will cancel, and this 3 is going to become a 1, this 15 is going to become negative 5 if we divide both sides of the top and bottom by 5. So this is ultimately going to give us negative 5. Negative 5 times 1 is still going to be negative 5. Okay, looking at B. You know what? Here, why don't you try B as well? Try B. Okay, so I will go over it. Negative 5 over 8 multiplied by 4 over 3. Again, this can be simplified. I'm going to divide both sides, top and bottom here, by 4. This is going to give me 2, and this is going to give me 1. I have negative 5 times 1, which is 5. I have 2 times 3, which is 6. I get negative 5 over 6. Ooh, next up we have improper fraction. Don't forget to convert them into an improper fraction first. Again, I'm going to give you a chance to try this problem. Good time to pause the video. Okay, and I will play this one. First converting these to improper fractions. Don't forget the negative. So I'm going to have negative 4 times 5 is 20, plus 1 is 21 over 5. And then I'm going to divide by this number, which is also negative. 3 times 5 is 15, plus 1 is 16 over 5. Okay, and next up, I'm going to flip the fractions around. So I get negative 25 over 5. First one stays the same. Multiply by the second one, but the inverse, negative 5 over 16. And guess what? Few things tend to cancel out. The 5 cancels out. And 16 and 21, does not cancel out. So we just have to multiply this one out. We get negative 21. Guess what? Two numbers are negative. We're going to get a positive number in the end. So we can drop the negatives altogether. 21 times 1 is going to give me 21. 1 times 16 is going to give me 16. This cannot be simplified anymore. I have 21 over 16. Oof, 2 more to go, guys. Oh, hey, look at this. I have solved the following. I need to solve for n. I have n is something, n divided by something is going to give me 9.62. So you might be thinking, well, if I don't know algebra, how do I figure this out? You might think that, oh, well, since dividing and multiplying are opposites, don't I just multiply this as a result? You know what? In this one, you will be correct, but let me show you something, and I'll show you why. Whenever you're confused of what to do with a math problem, the easiest thing to do is to think of a similar problem, but the numbers are easier to work with. For example, I have n divided by this. Let's make up something up. Let's say I have n divided by 5, and let's say that's equal to 2. Okay? For example, something divided by 5 is equal to 2. You know that 10 divided by 5 is going to be equal to 2. So what do you have to do with 2 and 5 to get you 10? You said it, multiplication. So you're absolutely right. You had to multiply these two to give you the n value, in which we know that a positive times a negative is going to give you a negative answer. And we just have to put this in the calculator. 2.6 times 9.62. This is, looking ugly there. 25.012. 25.012. Anytime when you're reporting a decimal, if it terminates and it's easy to write down, just write the whole entire thing. If it keeps repeating off like that, let's say this is a let's say this is a trailing decimal, then I'd probably round it up to maybe the 10th place, just to show that this 1, 2 is really insignificant in comparison to the rest of the number. So, but it terminates, so that's easy to deal with. This one is going to be a little bit trickier to deal with, because we have the n, the one that we don't know, is being divided. So we got to be a little careful here. And again, if you're not sure, if let's say you don't have the algebra to be able to solve this one out, let's imagine a scenario. Imagine you have a number, let's say 10, exactly the same thing. 10 divided by something is going to equal 2. I'm going to use exactly the last example there. So if you want to try to figure out n, then you have to think about what you want to do with the 10 and the 2. And you'll notice that you can't really multiply 10 and 2. That's going to give you 20. That doesn't give you n. It's going to make the statement false. So note the reason why that you can't multiply here is that division order matters. Multiplication is the opposite. Multiplication order does not matter. But what we can do to get n here is that we take 10 divided by 2 is going to give us n, which is 5, according to our previous easy example. So if we want to take 10 divided by 2 using this nastier looking problem, that's going to look like this. Negative 5 over 8 divided by negative 15 over 56. Okay, so let's we got to work this out now. We got to flip this around. And after flipping it around, we're going to get negative 5 over 8 multiplied by 56 over negative 15. And hey, you know what? There's two negative numbers here. They're going to cancel out, become positive. And something else also cancels out. because if I divide 56 by 8, I'm going to get 7. And 8 divided by 8, that's going to give me 1. I'm going to divide 15 by 5, that's going to give me 3. 5 divided by 5 is going to give me 1. Woo, look, we got a simple fraction to work with now. I basically have 1 times 7 over 3. So the answer here is just 7 over 3. Yay, very nice number to work with. Okay, and guess what? If you don't trust your answer, feel free to put it in to end just to double check. So what that looks like is the following. I have negative 5 over 8. If I divide it by 7 over 3, I should get negative 15 over 56. So again, I can just quickly do this just to check my answer. I multiply by 3 over 7. This is going to be negative 15, and 7 times 8 is going to give me 56. So my answer checks out. Okay, there you go. This is dividing rational numbers. I'm sorry this video took a little bit longer, but hopefully you enjoyed Tragedy Looper and the artwork on that board game. Thank you for watching. Good luck with your practices. Fat Mama Physics signing out.